Saxon Algebra 2, Lesson 48, Radical Equations. You guys, we have done a lot of radical expressions where there's no equal sign, but today we're going to, I just dropped my book. We're going to delve into the scenario where we actually have an equal sign with a radical, and we need to, see, look, I dropped my book, so I'm flipping back. Look, 27, radical expressions. We've been doing radical expressions for quite some time, 21 lessons. But we have not dipped our toes into the water of radical equations because they have some quirky little rules to them. But that's okay. We can figure out how to solve them, and you will be feeling so smart. Example 48.1. Solve. What in the world? We have variables inside of a pig house. And we have to solve for them, which means somehow we have to isolate that x, right? We have to get the x by itself. That's always the goal of solving in an equation. And we need to get rid of this pig house. Now, the best way to get rid of a pig house is to neutralize it by squaring it, right? Taking the root and raising a power are opposites. So what we want to do is that, because that will cancel it out, right? But in order to do this, we have to get rid of this. So the first thing we want to do is get this chunk by itself on one side of the equation. And we call that isolating the radical. Okay, we have to get it by itself before we can square it, all right? So I'm doing this first. Pretend that squared part isn't there. Okay, now I've isolated the radical. That is what I need to do. Now I'm ready to square it. And I get x minus 4 equals 64. Add 4. And we get x equals 68. All right. That's pretty cool. And it's right. But here's the thing, you guys. With these problems, there's something wonky that happens when we square both sides that sometimes will create what are called spurious solutions. The shock. So what we always have to do when we're squaring up like this, we need to check our answer to make sure it works. And that's the most annoying thing about these problems, is that you do have to check the answer. All right, so all we have to do is plug it back in. So what I do is I write check, and then I plug into the original equation. So that was 68 minus 4, right? I'm plugging 68 in for x, minus 2 equals 6. Okay, 68 minus 4 means it's 64. The square root of 64 is 8. 8 minus 4, no, I already did that. Right, 64. 8 minus 2 equals 6. And that's true. So that means our solution checks. Okay, let's try one where it doesn't work. I'm going to make it fit right here. Example 48.2. And I'm pretty sure this one's a dud. Okay. We always begin by isolating the radical. Okay, so there's my radical. Goodbye. Minus 9. Now we're ready. Now that the radical is isolated, we square both sides. I'm going to write that down up here too. Those are the 3 steps. 1, isolate the radical. 2, square both sides. And solve. I'm not going to write that. You guys know how to do that now. And then 3, check the answer. I'm pretty happy with those puffy clouds of knowledge, you guys. That's pretty awesome. Okay, so now we square both sides. And they cancel each other out. So this is just x plus 4 equals minus 9 squared is 81. Because that's where the drama comes in. That's where the squaring of both sides will cause problems, is when there's a minus over here. Then we subtract 4 from both sides, and we get x equals 77. But does it work? Let's try. Check. Okay, on the test I want to see you write that. Square root of 77 plus 4 plus 2 equals minus 7. That was our original problem, right? You plug it into the original. This is 81. Square root of 81 is 9. 9 plus 2 equals minus 7? No. So even though this was our answer, we write no solution. And we can also write null or empty set. So what I would want to see on the test for a problem like this is I would want to see your solution. Then I want to see where you check it and you show me that it fails. And then I want to see that you go back and say, never mind, that doesn't actually work after all. No solution, empty set, null set, or it's null set, empty set. And honestly, I like all 3 of those written there. There are 3 ways of saying the same thing. All right. We have 2 more, and then we're done with this lesson. Shocking, right? So fast. Solve. Okay, isolate the radical. Add 3 to both sides. Square both sides. Add 3. Looks good, so I box it. Then I check. Go back to the beginning. Square root of 67 minus 3 equals 5. First original problem, right? 67 minus 3 equals 64. Square root of 64 is 8. So I can gently cross that off because I reduced it all to 8. 8 minus 3 is 5. True or yes, whichever you prefer. You can write true or false, or you can write yes or no. And so this is the final solution, okay? So this is part of the answer too. Right? John writes check, but I wrote check there. Okay, 1 more. Ready? This one's a little wackier looking. Ready? Because the pig house is just stupendous. I'm all for a stupendous pig house, aren't you? Oh my word, what the heck is going on? This is a mess, And no, we've never had an x over there before. We always just had a plain number. Well, we're going to deal with the drama. Steps are exactly the same. Isolate the radical. All right, so we don't even worry about factoring that because we can't. Nothing multiplies to 13 but 13 and 1, and start to panic. But I'm wrong to do that. First, just isolate the radical. Trust the process. Notice that we have x plus 3 over here now. That's weird. Okay. Now where's my list? Can you see it? Square both sides. Okay, that's the same. But look what we have to do. We have to square it as a binomial. We can't just do x squared plus 9. We got to take these kids to the dance. All right, fine. Over here, we're good though, right? And this is the thing that happens with these problems that I kind of get a kick out of. When we started out, let me use your page to cover it up. When we started this problem, all the drama was on the left side, right? The right looked fine. Here, let me do it like this so it's not so cluttery. All the drama was over here on the left side of the equal sign, and we just had a plain x. Then we isolate the radical and we square both sides, and look what's happening now. The drama is shifting. This is now nice and cute, but now we have to do this whole crazy thing, right? So the drama shifts from the left to the right, and I think that's an interesting thing about these problems. All right, we have to square this binomial. I am going to do that over here. I've been talking a lot to other students about how you can organize your work, show all the things you need to show, and still make it look cute. Sometimes people really get into the visual aesthetic of their homework, and they don't want to show these weird little calculations, but we have to. So find a way to make it look cute, and I like to do these little bump outs sometimes so that it kind of stays separate from the rest of the problem. All right, so we're squaring the quantity, but we know how to do this. It's the dance, right? She goes with that guy, x squared, then we have 3x. She sits down, it's her turn, 3 times x is another 3x, and then we get the 9. So when we add them up, we get x squared plus 6x plus 9. You may be starting to be able to do those in your head. I still want you to show them. Next year, we will drop that, and you can do these in your head whenever you like. But for this year, I still want to see it. Okay, so this now is what goes over here. X squared plus 6x minus 9. All right, so now we have a trinomial on both sides. So let's do this. Let's bring all of these. Let's swim everything over here, combine them, and see what we get then. So I'm going to subtract x squared from this side, but look. What? And I'm going to add 9. I'm just going to bring everything over here. This all cancels out and becomes 0. And look what cancels out here. The x squareds cancel. I get minus 4x plus 22. I'm looking at my answer. Something went awry. Plus 9. Oh, this should be a plus 9. Sorry, my bad. That should be a plus 9. Then I'm subtracting, and then I get 4. There. I don't know why I turned that into, I just went crazy and turned that into a minus 9. but it should be a plus 9 here. Then then we subtract to swim the fish, right? So then over here it comes in as a minus 9. There, okay. So now I have minus 4x plus 4 equals 0. I'm going to swim that back over. Now that, I'm going to add it. 4 equals 4x. Okay? Yay. Now, let me just say something. At this point, the reason I decided I wanted to get everything on one side to see if I still had a trinomial, or if, as it did happen, things broke down. If I would have had a trinomial left, I would have wanted to see all the values together to see if I could factor it by inspection. As it turned out, the x squareds went away. I didn't have a trinomial anymore, and I ended up having to swim one of them back, right? I ended up having to bump him back, but I didn't know that in the beginning. So that's my advice to you, is when you have a big assortment of factors on both sides, push them all together, see what you get, and then you may end up swimming somebody back, but put them all together until you see what you've got. All right? So as soon as you see squared terms come up, shove everyone to one side and see what happens. Okay, and the last thing we have to do is check. This is our original. So it's 1 squared plus 2 times 1 plus 13 minus 3 equals 1. Plugging the 1 in, right? So that means this is 1 plus 2 plus 13, which equals 16, square root. So all of this just boils down to 4 minus 3 equals 1. That is A. This time I'm going to show it with a check mark, and I'm going to call that my answer. Yay! Lesson 48. Guess what, you guys? We're done with our lessons for 2020. We made it. We did it. On our next lesson, our next video, it's not a lesson, it's a video, I'm going to start here at lesson 48 and go backwards through the lessons, telling you what's likely to be on the test, reminding you of formulas, and giving you a little bit more study material to cover on your review process. One thing I want you to do, I'm going to write it right here. Please draw this with me. The rules for exponents. They're important. And I want you to copy them down again. Even if you think, oh, I know those, please copy them right now with me. Okay, there are 3 rules. Product, quotient, I hope your boxes are bigger than mine, quotient, and power. Those are the names of the rules. Product rule, quotient rule, power rule. Here is the shorthand we use for them. If you're multiplying matching bases that have exponents on them, you can combine them by adding the exponents. When you're multiplying the bases, you add the exponents. Product rule, because product implies multiplying. Quotient rule, if you're dividing, or what I would say, you just have a fraction, right? You subtract. Exponent on the top minus exponent on the bottom. There it is. Power rule, you have a base. It's already being raised to 1 power, and now you have to raise it to another power. Now we multiply the 2 exponents, all right? We use these all the time, but unless I really push them into your brains hard, I know that they tend to fall out over and over and over again. So if they're in your brain already, lucky you, you already know. If you kind of get them and you know how to use them, but you forget all the time, trust me, just memorize it one more time. I'm going to ask you to do this on the test. Okay? So just memorize it. Please start now. You're going to need to memorize a lot of formulas for this test. Hopefully you've got some of them pretty well settled in your head, but please memorize this so that you'll have it when I talk to you on Monday. All right, congratulations. Celebrate. Do your homework. Talk to you soon.